Hi class, here is a quick video covering those last two examples on class Q for the difference quotient. So the first one is to find the difference quotient for f of x equal to 3 over x. And I think it's a good idea to write down what f of x plus h is. So f of x plus h is going to be, instead of 3 over x, it's going to be 3 over x plus h. So then f of x plus h minus f of x all over h is going to be 3 over x plus h, and that's my f of x plus h, minus 3 over x. I'm going to mess up a little bit of room here to do something. All over h. And now, to subtract these two things together, I need the common denominator. So multiply this by x over x, and this by x plus h over x plus h. And unfortunately, this really is the only way we can do it. You can't just add on an h here. The only way you can change the denominator is to multiply it by something. So then, we're going to rewrite this as 3x, right, 3 times x, over x plus h times x, minus 3 times x plus h, over x plus h times x, which is the same thing, all over h. Now, instead of saying divided by h, I'd like to not have fractions and fractions. I would say this is h over 1. And so really all of this is going to be multiplied by, instead of dividing by this, I'm going to multiply by the reciprocal, which is 1 over h. Great. These two fractions I can put together because they have a common denominator. So I can write this as one fraction where the denominator is x plus h times x, or x times x plus h, x times x plus h, whichever way you want to write it. And the numerator is going to be 3x minus 3 times x plus h. So that's like that, times 1 over h. When you have fractions times fractions, you can multiply the top by the top and bottom by the bottom. So I can write this as the denominator is being x plus h times x times h. And the numerator is 3x, and if I distribute the minus 3, I get minus 3x minus 3h. The 3x's cancel. I got so many pens in my hands. Sorry. The 3x's cancel. Boom, boom. And now I can rewrite this as minus 3h over x plus h times x times h. And this h here can cancel with that h there, right? The h's that are multiplied by everything. You don't have to factor an h here on top because there's only one h on top, or only one term on top, I should say. And then finally, my answer is negative 3 over x plus h times x. And that's our final answer. If we were doing calculus, we take the limit as h goes to 0, and then we get negative 3 over x times x, or negative 3 over x squared. But we're not there yet. Our answer is just negative 3 over x plus h times x. I do want to point out that just like the other examples, the original h in the denominator, oops, it's right there, right? That original h ends up canceling out. That is always what's going to happen, is the original h in the denominator of our original expression is going to get canceled out. That's always the goal. Let's look at the other example, where our function f of x is the square root of 5x plus 1, and f of x plus h is the square root of 5 times, not x, but x plus h plus 1. So now, to find the difference quotient here, f of x plus h minus f of x all over h. Again, we're looking to cancel that h out eventually. So we do the square root of, I'm going to simplify this a little bit and write it as 5x plus 5h, so in parentheses, right? Distribute that 5. So you get the square root of 5x plus 5h plus 1 minus the square root of 5x plus 1 all over h. Now, when you're trying to simplify a difference quotient like this and you've got a square root minus another square root, the only way you can really attack it is by multiplying by the conjugate. So the conjugate of a square root minus a square root is the same square root plus the square root. Or if it was a plus here, it would be minus. Basically, a conjugate is just the same expression with the opposite sign in the middle. So I'm going to multiply by the square root of 5x plus 5h plus 1 plus the square root of 5x plus 1. But I can't just multiply by anything I want. The only thing I'm allowed to multiply by is 1, because that's the only thing that doesn't change the thing. So I'm really multiplying by the square root of 5x plus 5h plus 1 plus the square root of 5x plus 1 over the same square root of 5x plus 5h plus 1 plus the square root of 5x plus 1. Here's what happens. Nothing really happens with the denominator. It's just going to be h times all that stuff. H times square root of 5x plus 5h plus 1 plus the square root of 5x plus 1. And again, we want this h to cancel out, so we don't want to distribute it through because we know we want it to stay out so we can cancel it. On top, when you multiply conjugates together, right, when you multiply a minus b times a plus b, you get a squared minus b squared. And the middle terms, which would be ab and negative ab, cancel out. So in this case, if this is like our a and this is like our b, we're going to get a squared minus b squared. The square root squared is just what's in this inside, so it's going to be 5x plus 5h plus 1. Sorry, this thing squared minus this squared is going to be 5x plus 1. And we do need those parentheses because we need to make sure we distribute the minus sign. So, distributing the minus sign, I end up with 5x plus 5h plus 1 minus 5x minus 1 all over that same denominator, h times the square root of 5x plus 5h plus 1 plus the square root of 5x plus 1. And now we can see on the top that the 5x and the minus 5x cancel out, and the positive 1 and the negative 1 cancel out. But if we had forgotten to distribute the minus sign, and just it was minus 5x plus 1, the plus 1 and the plus 1 that would have been there wouldn't have canceled. So if the things on top that aren't h's don't cancel, we know we've made a mistake. Because again, our goal is to cancel out that original h, and the only way you can cancel out the original h in the bottom is for eventually the numerator to have only things that have h's in it, which means all the not h things have to cancel out. So then the 5h over h, so we've got 5h over h times this big square root plus the other square root. 5x plus 5h plus 1 plus the square root of 5x plus 1. And then we can cancel this h with that h. And we're left with a final answer that is 5 over the square root of 5x plus 5h plus 1 plus the square root of 5x plus 1. Again, just like in the previous example, and really all of our examples, the original h that was in the denominator ends up canceling out. That's always what we're looking to make happen. All right, I hope this helps with your homework, and I will see you all on Monday.